This is the RunSafe Security Minute. We're here to provide 1-minute security briefs. Today's question is,
Shane, why is RunSafe's load time function randomization better than control flow integrity and address space layout randomization?
In the case of our load time function randomization, what we mean there is every time a program loads or a library is loaded, we randomize the order and layout of all the code in that binary or that library. So we do it at a very high granularity, which allows for a lot more possible permutations. So as we compare to address space layout randomization, I'll start there because it's a little easier. ASLR moves your entire program around in one large chunk. And so if your program has one information leak, then an attacker is able to take that information leak, reverse engineer where all the code ended up in memory, and produce a very reliable and robust exploit. And so we see that as ASLR has gained mainstream adoption. It was introduced back in the mid 2000s, and it made exploitation harder, but it hasn't stopped attackers from exploiting systems. And so that's because those information leaks can be used to easily undo the ASLR and then build a reliable exploit chain. So as it relates to ASLR, our functionality is better because you can leak the address of one function, but you don't know if that's the first function for this randomization or if it's now the 72nd function. And it's really quick to get into just insanely large numbers of functions. So, if you think about the number of functions factorial, that's the number of possible orderings. Most programs have over 200 functions. And even if you get to 100 factorial functions, that's, I don't even remember. It's a huge, huge, huge number, more permutations than there are atoms in the universe, multiple times over. So, really great randomization there. And I should say that our functionality at load time to do that function randomization is complementary with ASLR. So for systems that are already doing address space layout randomization, you should continue to do that. But we can be a complementary solution there to provide a lot better security on top of that. And if you don't have address space layout randomization, like say in VxWorks 6.9, we can provide that randomization that you wouldn't otherwise have available to you. And then as it relates to or compares to control flow integrity, one of the things that's really great about our load time function randomization is the low performance overhead. So we break that down into a load time overhead and a runtime overhead. On the load time side, you typically see 1 to 3% additional time to load the program. So if it takes you 100 milliseconds to load your program normally, it's going to be 101 to 103 milliseconds. It's really low. And that's just because we have to do that randomization. We have to move all the code around, fix everything up. But then once you get to runtime, once the code's actually executing, we're not really involved at all in execution. And so that allows us to have effectively a 0% performance overhead. And we say effectively because in some cases you may have processor cache hits turn to processor cache misses, but the inverse might happen as well, where misses turn into hits. And so we've not yet had a customer be able to measure a difference when we're deployed versus when we're not deployed, as far as like runtime throughput and performance. So we can be extremely low performance overhead. Whereas on the other hand, control flow integrity can be, depending on the implementation, anywhere from 5 to 30%, sometimes higher. And as you get to the lower performance overheads, you're seeing kind of a more broad implementation of control flow integrity that can be defeated in a bunch of different ways. So that can be problematic, right? The other thing that makes control flow integrity really difficult is that oftentimes it's not possible for the compiler to know all possible functions that you might be able to call from another function, or all the functions in code that could call to a given function. And so you can turn it on broadly and then everything breaks, or you have implementations that are less strict, which then you get less security around. Now, that said, we do support running our load time function randomization in environments that are doing control flow integrity as well. So again, we can be complementary to that approach, but if performance is really important to you, if just being able to make a small change to your build environment and not have to worry about code breaking, our load time function randomization with RunSafe code is really a great solution for that.